Since demo observer class outputs the diagnostic information to the logcat console, here it will be easier to see the output if the filter is configured to display the demo observer messages here. Oops, actually, what's that? Yes, we have to delete that. Okay, so now we will actually click on demo observer here. As you can see, we have log tag, which is we always put on the first parameter in log.e option method actually. So then let's click on logcat here, so filter the our logs here. Click on that and click on edit filter configuration here. Then log tag here, write log tag here, demo observer here, and click OK. So as you can see here, our log tag is always demo observer, and we're using this string, and we now edited this string. So let's change this name as well, observer here, and then click OK. So now let's launch our application here by click on run button, or I'll shift F10, and here our Android virtual device is opened here, and now we are waiting. So in previous lecture actually my Android virtual device is crashed here for some reason. Then I created a new Android virtual device. Now we can use this. Now it's building here. Now we can close this. As you can see here, the first is onCreate method. Actually, let's so as you can see here, our activity is first create method here. So what is this? This is the, as you remember, we have declared on any function which is getting owner lifecycle current state name, and this is the current state name. So on any lifecycle event triggers on any lifecycle events here. So if on start, the on any triggers, on resume, on any triggers, as you can see here. So our lifecycle is firstly created and then started and then resumed. So now what if we rotate our device here and click on this for rotating? As you can see, after that our application is paused. Actually, yes, our application is paused and then stopped here, and then destroyed here, and then created, destroyed, and then created, and then started, and then resumed here. So what if we click on that application section here? As you can see here our application is paused and then stopped. Now if I click on this again, as you can see, our application is started and resumed. And if I close application entirely here, and then as you can see here, on stop, actually on stop here, and our application is here. Let's rotate our screen and let's open it again, and then here first on create method executed, triggered actually, and then on start, and then on resume. So before moving to the next lecture, so take some time to compare the output from the application within the flow chart here. Now let's add a lifecycle owner here. So the final task in this actual chapter here is to create a custom lifecycle owner class and demonstrate how to trigger events and modify the lifecycle state from within the class. So now we will add a new class on the application here, in the project tool window here, and click on right click here and click on Kotlin file class here and name this class demo owner. So now our demo owner in the create class dialog, and with the demo owner.kt file here, we need to import some lifecycle, some classes from lifecycle package here. The first is import androidx lifecycle here. Then we will import a lifecycle owner class from Android lifecycle package, lifecycle owner, and then we will lastly import Android lifecycle registry, lifecycle androidx lifecycle registry here. So as well, this will inherit lifecycle owner class, lifecycle owner here. So the class is going to need lifecycle registry instance initialized with a reference to itself, and the get lifecycle method configured to return the lifecycle registry instance. So declare a variable to store the lifecycle registry reference. So a constructor to initialize their lifecycle registry instance and add the get lifecycle method here. So now we will do all of this. So first let's declare private val here. This will be lifecycle registry here, and this will be lifecycle registry type here. And then let's add init here. Lifecycle registry here is assign it to lifecycle registry this here we providing, and then we have to override the function here, which is get lifecycle override function, get lifecycle here, as you can see here, and this return lifecycle registry here. So the next the class will need to modify the registry of lifecycle state changes here, like start owner, stop owner. So this can be achieved either by marking this state with the mark state method of the lifecycle object, or by triggering lifecycle events using the handle lifecycle event method. So what contains this state within a custom class will depend on the purpose of the class. For this example, we will add some methods and simply trigger lifecycle events when called. So we will add a start owner here, and this will be lifecycle registry that handle lifecycle event, and then a lifecycle event, lifecycle dot event dot on start here, and then we will add another function here, stop owner here, and this will be lifecycle registry handle lifecycle event here, and lifecycle that event here on stop here. And then as you can see, we have a get lifecycle method as well here. The final change within the demo owner class is to add the demo observer class as the observer. So this call will be made with the init constructor here, like this. For example, lifecycle lifecycle dot lifecycle add observer here, and we will add demo observer here, and add this braces here as constructor here. So load the main fragment Kotlin file into the code editor here, locate on activity created here, and add the code to the create an instance of the demo owner class here, and to call the start owner and stop owner methods. Note also that call to the to add the demo observer as an observer has been removed here, so we don't need any of this observer here because we added already here add observer demo observer here, so we don't add twice. We don't have to add twice these observers here. So now, although a single observer can be used within a multiple owners, so it's removed in this case to avoid duplicated and confusing output within the logcat window. So it may throw some exceptions, or may it throw and double this, for example, twice and as on assumed here. So let's initialize our owners here. So let's import firstly import, so we don't need demo observer import here. Now we will import our demo owner. So import take pins lifecycle demo here. This will be demo owner here, and then we will create an object here, which is going to be late init. We will initialize later. So private late init var here. This will name demo owner here, and then we will initialize this demo owner as the demo owner class demo owner here, and we will use these methods here, demo owner dot start owner and demo owner dot stop owner here. So build and run the application one final time here. And let's add here and clear our life cycle here. So let's close our application here and delete from last used here. So now we will add for launch our application here. As you can see here, our methods are worked. So note that the create state here, this changes were triggered even though the code was not added to the demo owner class to this manually. As you can see here, we have not added demo owner any of these methods here. We added just an observer to demo owner, and we used demo owner in our main fragment. So in fact, this was triggered automatically, but when the owner instance was first created, and sequentially when the onStop event was handled. So this lecture, actually this and previous lecture, provided a practical demonstration of the steps involved in implementing lifecycle awareness within an Android application. This included the creation of a lifecycle observer and design the implementation of a basic lifecycle owner class. So thank you for watching my lecture, and I'm waiting you in next lectures.